All right. Good morning. Thank you for joining us today. This is I believe, our 7th Career Ed Talk, and we are in the field of engineering and technology education. I am going to do a quick screen share. All right. So these are the Career Ed Talks, the virtual career panel series that we have every 2 weeks, Wednesday mornings from 9 to 10. Teachers, you're able to access the recordings on our YouTube channel. And this is what you'll see when you get there. Today, we are covering engineering and technology education. So in our secondary courses, so our high school courses, you can see what we offer. It includes aerospace, applied engineering, applied robotics, communications technology. So you can see all of those here. And we'll quickly pull up this infographic. So currently there are a little bit less than 50,000 enrollments in high school programs that cover engineering and technology education. Students, you'll need mathematics, science, technology. The top high school programs are engineering pathways, and then you can see applied engineering technology all the way down to technical design. So this would be your articulation pathway. And then here are your certifications that you could be working towards either in high school or post-secondary. Go ahead and stop sharing and we will go ahead and get started. So we are happy today to have from LCEC, we have Bill Piland. He is the Design and Engineering Services Manager. We also have Shawn Walling. He's the Construction and Maintenance Substation Manager. And from Barraco Associates, which is an engineering firm, we have Jeff Wasko, and he just passed his professional engineering exam. So congratulations, Jeff. We'll go around and do a very quick introduction. If you could just introduce yourself, tell us what your current position, kind of a day in the life is, how you got to where you are, any sort of education background needed for your position, certificates, degrees, things like that. So let's go ahead and start with Jeff.
Sure. How's it going, everybody? Well, I'll start first that I have a degree from FGCU and a bachelor's of science in civil engineering that took me many years to get. And there's 2 steps after that to becoming a professional engineer, or 3 steps, which is an exam right after your college degree called the Fundamentals of Engineering. And then you need 4 years of work experience, and then you're eligible to take the professional engineering exam. And if you want to know a little bit about what a civil engineer does, we here in our office, we do residential development. So we design, plan all the infrastructure, so lakes, underground utilities for residential communities, gated communities, commercial developments, municipal roadways, all kinds of stuff. Really, anytime that you go anywhere or get water from the tap or flush a toilet, that's what we do as civil engineers in my field. I chose this career because from a very young age, I've always been interested in taking things apart and knowing how things work. And it just kind of led to a natural progression of doing things in the design field. When I was in high school, I did take drafting classes, and I learned how to use AutoCAD as well as hand drafting, and that from there that led me into jobs right out of high school that I got as a draftsman and worked my way through college using those drafting jobs. So I did see on the list there that you guys do have some accreditations available in AutoCAD. I would suggest if if any of you have an interest in the engineering field, get those degrees and just start applying places. There's plenty of jobs out there for part-time CAD technicians, summer jobs, and there's a lot of people in the community, in the engineering community, that would be willing to give young people a shot, especially ones that are really up on the newest technology and really know how to use it.
Awesome, thank you. Let's go over to Shawn.
Good morning. I want to start out by telling everyone who watches this how blessed and lucky you are to have an opportunity to be in this and be exposed to science, technology, engineering, and mathematics careers in high school. Longer than I want to think ago, when I was in school, opportunities like this weren't out there as much, so you kind of had to learn by trial and error instead of having someone be able to guide a little bit and help you get through that. I've started out, my degrees are in chemical engineering. I too am a professional engineer. I've been one for, again, longer than I care to think about. Jeff did a good job explaining the process. Professional engineering certifications in some fields, especially civil that Jeff's in, are very, very important to be able to do work. In some other engineering fields, they're not necessary. What that license does is basically lets the state certify that you're an engineer and you know what you're doing and work on projects that directly impact public safety and public health. I've got about 20 years in the electric utility industry. Lee County Electric Co-op, we're the people that bring the power to your house or your school. So if you're sitting there with the lights on, the air conditioner, or the heat running, that's because we're doing our job and keeping the electricity flowing. We're the utility. We're regulated. We're not in competition with other areas. So there's multiple levels of types of engineering jobs there. My day in the life, I show up in the morning. I'm on the operations side, whereas we have keep everything operating. You have design engineering on one side where you plan to make everything work, and then you have the operations side where it gets built and gets operated. So typical day in my life, we show up in the morning and we have a plan for maintenance to keep everything running. We have a plan for all sorts of preventative maintenance, checking stuff, making sure stuff's there. And then when we get to work at 7 o'clock in the morning, we check our email and check our phone calls to see if anything needs attention right away. And the operations side's a lot of planning, but also a lot of reacting. I think that's, I could spend hours discussing, but I think I'll stop there and we'll move forward.
Thank you, Shawn. And last but not least, Bill, thanks for joining us today. Bill, can you kind of go over what a day in life is like for you? I know you're more on the design side, so maybe explaining the differences between what you do, what Shawn does with LCEC.
Sure. Good morning, everyone. I am the manager of design and engineering at LCEC, and I'm responsible for a group of engineers, design assistants, staff assistants. I've got 37 total employees, and we're on the front end of the projects that Shawn talked about. So we do the planning and the engineering work, design, create the construction drawings, and Shawn's group takes that and actually builds whatever it is that we've designed and maintains the infrastructure also. I've got a Bachelor of Electrical Engineering degree from Auburn University. I've been at LCEC for 32 years. I started out as a planning engineer, and I've held several different engineering jobs in distribution protection, relaying protection, skate engineering. I was a supervisor for 8 years before moving into management. When I first started college, I started as a business major. And for a while there, I took a computer science class and became interested in computers. So I changed my major to computer science. Then I took a physics class and became interested in engineering. The school I was at didn't have an engineering program, so I transferred to Auburn, where I enrolled in electrical engineering. You know, as long as I can remember, like Jeff said, I've been curious in how things work. When I was about 10 years old, I took apart a vacuum cleaner that my parents had thrown out because it stopped working. And when I took the motor apart, I found magnets and coils of wire and didn't really understand how all this worked, and definitely wasn't able to fix it. And also, you know, this was before we had access to the internet. So I couldn't Google it. I couldn't watch a YouTube video on it. So I went to the library and checked out a book on motors. And a couple of years later, when I had to do a science project in school, I actually built a simple DC motor using magnets and coils of wire. And this was to demonstrate the effects of electricity and magnetism. So, you know, my curiosity of how things work is really what led me to engineering. So any of you who are in that same boat, you know, you're curious about how things work, you know, engineering might be a good field for you.
Thank you. Thank you for sharing. And I really appreciated that you were honest in saying that this is not your first choice. You went to school to do something else, and then through experimenting and exploring and finding different things, you kind of changed your path a little bit. And I think that's very important for our students to remember, that it's okay to change your mind if you find other things that you like and you enjoy. It's also important to try different things so that you can kind of narrow that search down a little bit so you can find your pathway. One of the things that the students really enjoy is hearing your personal stories. So not to put you all on the spot, but can you think of some sort of memorable story of a time in your career? So something that was funny that happened to you, something that was very memorable, something that you learned, some kind of situation that's a personal story to you. Let's start with Shawn.
Memorable stories. Again, to just expand a little bit, my career started out in power plants and worked its way over to the distribution side. So I've been from making the electricity all the way through to bringing it to your house. One of my most memorable events was a power plant that we actually, it was about 35 years old. So part of the plant was starting to deteriorate due to age. And the decision was made to replace parts of it and keep it working. And it was about a 4-year project. And during that 4-year project, we were under a time crunch, but because we had a set date where we had to start the unit, I spent a lot of time. I was the control system engineer there. I was the person that installed all the equipment in the field and made sure it worked. So the control room operator could sit at the desk and push buttons on a panel or on a computer screen and generate electricity. And one of the things that we always found humorous is since the plant was being repowered or rebuilt, the start date was set. It was the 40-year anniversary of when it was initially commissioned. And as happens often in schedules, what turned into a 3.5-year project turned into a 4-year project. So we ended up having to start the power plant when we haven't had quite enough time to get it all the way through the testing. So we were sitting in the control room as a 24, 27-year-old kid running a power plant and hoping that nothing tripped, because we had politicians, we had political leaders, we had business leaders, we had people from all over the state there watching this, and we were all sitting in the room trying to make sure nothing popped up that was going to cause the power plant to trip and cause massive embarrassment to all my bosses, which would not have been good for me. And as soon as everyone drove out of the gate, you could actually feel the air pressure in the room change when everybody exhaled and said, it's okay to turn the plant off now, because we survived the commissioning ceremony, which that was one of my more memorable moments, because I think after we got done with that, I was able to sleep for about 12 hours straight, because the stress had been relieved, and then come back the next day and finish up all the stuff that we were supposed to have got done beforehand. But we were able to make it work, because sometimes deadlines are set and that's what you meet.
Good story. No pressure, right? No pressure. All right.
Not much. I mean, it was entertaining.
Let's go ahead and go to Bill. What is one of your most memorable stories?
Similar to Shawn's experience, it was me rising up to a challenge. When I first started, when I first started, we had fewer people doing the engineering in our company, and everyone was specialized in a certain area. At that time, I was doing planning engineering. And the person who was doing relay engineering for our substations left the company, which left a void. And we had several projects that were in progress that had to be completed. So my boss at that time asked me if I would fill in and complete those projects, which I had no experience in doing that type of work. So I spent a lot of extra hours at that time doing some research and teaching myself how to complete that work. But I was able to do it, and it really made me feel good about myself rising up to that challenge.
Awesome. Good points too about possibly having to spend a little bit of time getting outside of your comfort zone to teach yourself to do other jobs to make yourself more marketable to your current position. So good story. Thank you for sharing that. Jeff, you're up. Oh, you're on mute.
Sorry. Well, kind of to expand on what Bill was saying, and Shawn as well. What I find memorable, and especially me being more younger in the engineering field, your first few years, everything you do is in an increasing level of responsibility. So I would say that my most memorable moment is taking a project all the way from start to finish, where we have just a wooded piece of land that's essentially, everybody sees every single day, just driving by is some woods, and then a few years later you're driving by and it's a complete development, and you know that you worked on every single part of that. So all throughout the zoning process and the planning process, and then designing the actual infrastructure, the water management of all the lakes, and then all the way up until a home's being built on that piece of property. To me, that's memorable. I mean, I still think about the very first project that I got to take from start all the way to finish, where they closed out and people now live there.
Can you tell us where it is?
Sure. There's quite a few of them now. The first one that I got to take from start to finish was right off of Ortiz, right across from the jail, actually. There, but yeah, that was the first one that I was involved in every single part of the entire process.
That's awesome. That's really cool. Being able to see it, like you said, from just a bunch of woods to now people actually live there and have their families there, and that's their home. Really cool. Mr. Shell, we're going to turn it over. Do your students have any questions? Anything that they'd like to ask?
Sorry, I was helping somebody with the program.
That's okay.
Hold on one second, okay? I know Jacob has one. Hold on.
Okay.
Okay, I have a young man who wants to be a robotic engineer. And he wants to know what advice would you give him to become one of the best, to be really great at it? And if there's a school in Florida you would recommend for that.
Good question. Jeff, can we start with you? What would your advice be to a student and any top schools that you think are accessible here in Florida?
Well, I would first say, okay, so robotics engineering. I'm not aware of anything locally as far as education, but what I do know that I feel like a lot of students overlook now is there's a lot of opportunities for your undergraduate work here locally. So if I was trying to get into robotics engineering and I had a particular school that I was looking for and wanted to get into, I would figure out what their curriculum is, and I would see what I could do locally first. And as far as a practical side for having a job during college, I know there's, here in the South, we don't have as many manufacturing jobs, but I would look at anything that's in the manufacturing industry. I'd use what's available at my high school. I saw you guys can get the AutoCAD accreditation. AutoCAD work and drafting is not just for architects. It's every single thing that you design. I would learn how to use SolidWorks. I'd learn how to use AutoCAD, Revit, all those things that were available for free at the school. I'd want to use that knowledge and try to get into some kind of manufacturing part-time job here locally and get as much undergraduate work that I could do for cheap locally, and then transfer that to whatever robotics school of your choice in the future. I mean, that would be my advice.
Thank you. Very good point. I'm going to let Bill and Shawn answer as well, but to kind of speak to Jeff's point, students look into what's called a 2+2 pathway, 2+2 program. So you do your first 2 years at a state college. So locally, that would be Florida Southwestern. I know Indian River State College on the other side of the state does have a robotics program that's at that state college level. So you go get your 2-year degree, get all of those core classes out of the way that you would need for probably any engineering program. And then, like Jeff said, transfer into the larger university. You're going to save yourself some money because state colleges cost a lot less than state universities. And then also out of state, if you go out of state, that's going to be even more expensive. So look into those additional options, things that might not be on your radar. You don't have to stay at the same school and go all 4 years at one particular school. You can do your first 2 years getting all of those core classes out of the way and then transfer in. So that's always a really good option. Thanks for bringing that up. Bill, what advice would you?
That's good advice. Yeah, that's great advice. And I'll add that if you're going to plan to start your education at one school and transfer to the school that has the degree program you're interested in, research what those requirements are for the school of your final destination, because not all classes will transfer to that program. I experienced that when I transferred from one school to another. I lost some credits because they were not part of the electrical engineering program at the new school. Yeah, and I'm not familiar with which schools in Florida have robotics programs, but there's a lot of information online. So I suggest that you research that. And really, that's all I've got to add.
Good point. Thank you. Yes, have an idea in mind of what your end goal could be and make sure that you know what programs, what classes you need to go into that program, what courses you should be taking, so that if you do start somewhere else, you're at least still taking equivalent courses that will transfer. So thank you for that, Bill. Shawn, what advice would you have? Do you know of any really good, outstanding robotics programs?
I'm not familiar with any of the robotics programs, but I want to echo a little bit of what Bill said about making sure the classes will transfer, because Bill lost some credits. Not so funny story for me, but when I was in grad school at the same college I got my bachelor's degree from, I got called into the dean's office and told one of my freshman level classes didn't count, so I technically hadn't graduated. So we had to jump through some hoops to get that done. So make sure you pay attention to what the classes are and make sure they transfer. The going to local 2+2, that's a great option, because one, it saves money, and two, it'll if you're taking some of the classes locally at a college, you can have time to focus on them. Whereas once you get into the university and get into the program, I'm wanting to do robotics, so I'm going to focus on the robotics class, and maybe that U.S. history doesn't get the same attention that it might deserve. And you don't ever want to have problems with outside of your major classes. The other thing that I would bring up is that there are a lot of people who plan to go on to grad school if you're really wanting to focus on something to get a master's degree. And if that's what your long-term plan is, you can have the option of just going to a not quite as prestigious engineering school, getting your engineering degree, and then going into the grad school if it's out of state. Because typically at your research institutions for engineering programs, when you're in grad school, you actually get paid for being there. So in my case, now I wasn't getting paid very well, but I went from having to write a check to the university in November for my undergraduate to in January them depositing money in my account and paying for my school. So that's an option when you get into grad school. I was a teaching assistant. I was having to do research for other people getting their master's degrees. I was also doing research on my master's degree program. So the university ends up getting some funding from that. That's how they were able to pay me, but that's an option. And the one other thing for anyone out there listening that's thinking, I may want to do engineering, I may want to do something else. If you're not sure, which is perfectly acceptable your first few years, and honestly, I know people that are in their 30s and 40s that are changing careers, but when you're getting your degree, if you're making a decision between engineering and business, and you're looking at your freshman year classes, pick the ones that'll work for engineering, because if you take calculus and switch to business, calculus counts. If you take business math for a year and switch over to the engineering program, the business math doesn't go toward your engineering degree. So if you're having two things you're looking at, I don't want to say pick the harder classes, but pick the classes that'll work for you so you don't lose a year, and those classes typically count.
Thank you.
All of them.
Good, very good points. All very good points. Mr. Shell has sent me a chat with a couple other questions. What are the greatest skills that you need to have to be an engineer? Which is one of the questions that was kind of on my list as well, is, what kind of personality traits work well? What's a good skill that you need to have to be successful in the engineering field? We'll start with Bill. Oh, Bill, we can't hear you.
Sorry about that.
Okay.
So engineers tend to be detail-oriented. Most are logical thinkers, and they have the capacity to analyze complex problems or systems. They're usually inquisitive, and they enjoy learning. And they also tend to work well under pressure. So those are some of the, personality traits that I associate with engineers.
Jeff, anything to add?
I would say, I guess this would be more of a trait than a skill, but always being willing to learn more. And I guess not so much being willing, but already having that will or that want to always learn more about what you're doing. I feel that every single day when I come in, I'm learning something new, which is something that I really enjoy about my job. So I would say that is a good trait to possess. As far as skills, I am not I may be one of the few engineers that is not as detail oriented as maybe some of my peers are. So that is a skill that I've had to learn and develop. And it's something that I've gotten relatively great at, but it is something that I do have to work at. And I'm sure there's plenty of skills that can be learned rather than just innate.
Very good points. Shawn, anything to add?
No, I'll agree with what they said. You have to be detail oriented, but there are also multiple fields of engineering. There are some engineers and engineering positions where people are given a task and more or less locked in an office and told to come out when it's done. And that's one set of personalities where you have to be very detail oriented and focused on one thing. There are other engineering positions where you're doing things and whatever someone throws at you, you have to be able to handle and deal with it. Those are two completely separate skill sets. And when you get through in an engineering role, you typically tend to gravitate toward what your skill set is, because that's where you're best at. I've seen engineers that could think on their feet and fix a problem in 5 minutes and find a solution that would take another engineer I knew, a day and a half to come up with. But the person who took a day and a half to come up with, if you gave them a blank sheet of paper and told them to design something, they could do it from scratch in a day. And the person that thinks really well on their feet, you put them in a room with a blank sheet of paper, it's going to take them months to do. So the trick is to find your niche, find what you're good at, because the term engineer is kind of a broad range. You have multiple disciplines, and then even in the discipline, you have the day-to-day person that how do I deal with what just got thrown at me 5 minutes ago that I had no idea was coming, and then you have the person that's doing a 30-year long-range study on our electric grid. We have a 30-year plan on what we're going to have built in 30 years. So those are two separate skill sets. The other soft skill that really goes a long way is having some people skills, and that applies across the board in about anything, because there are people that I graduated with that you would lock them in a room and give them a piece of paper and they could do a lot of stuff, but you would keep them locked in the room because they're your stereotypical engineer that you didn't want to converse with because they had no personality. And this was coming from another group of engineers, so our scale was shifted a little to I won't say antisocial, but not quite as social as some of the other groups. So if you have some people skills, you can improve things and do well there.
Thank you for that. All good points, I think, in engineering or really in any career field, being able to communicate and find what you're good at, find what area you're passionate about, because if this is going to be your career, you don't want to not enjoy it. You want to enjoy it. You want to get to work and have fun at work.
I have one more thing that I wanted to bring up. One thing that I learned the hard way that someone tried to tell me, but when I graduated college, I obviously knew more than someone that had been working for 20 years did, is when you get out of engineering school, they say you have a toolbox. They teach you how to problem solve. They teach you the stuff that you need to know. But then when you get your first job, that's when you learn how to do your job. You don't come out necessarily knowing how to do a job. You come out knowing a thought process, knowing how things work, and that's what you're applying. So when you come out, when an engineer gets their first positions, the ones that really excel are the ones that understand rather quickly that, okay, I have all the book learning and now I have to apply it in the real world. And typically you have other engineers there that are willing to help you along. And once you get out of college, you learn how to do your job. You just use the tools you learned in college to get there.
I think Shawn kind of touches on an important piece too, in finding a mentor, find someone who can help you, whether it's now while you're still in high school, or once you do land that job, finding someone who's already been doing it for years that you can learn from. The next question that came in, I know there was one, how much math is involved in engineering? What is the top level of math? And I'll just open this up. Anyone that wants to answer this, feel free to chime in.
I will say I think it depends on what field of engineering that you're in. My day-to-day is kind of split between doing some project management and permitting stuff, which is a lot of conversing with the clients, making sure that the project's moving forward within the office. But then it is engineering, so there's obviously a technical side. I mean, this is a 144-page report that I just finished up, which is using modeling software and, the typical kind of graphs and that kind of stuff. So your math in college, you have to do it all. You pretty much have to take all the math courses that FGCU offers, at least. That's where I got my degree, was FGCU. You pretty much have to take them all.
So if you don't like math, we may want to find something else outside of engineering.
I'll chime in by saying I was 2 freshman level classes away from a math minor by the time I ended. But in college, my engineering program started out with Cal 1 and went Cal 1, Cal 2, Cal 3, differential equations, advanced applied, and then some statistics classes. As far as my day-to-day math, the last, let me see, but I'm in management now. So my last 6 months, I don't think I've done any math that couldn't be done by a high school senior. But the math I learned in college is what taught me how to do my engineering courses, which taught me how to think and how to do the things. Now, there's other people in our department or in the company that are doing high-powered math on a regular basis. We have modeling software we use, and one of the things is the computer can give you the answer, but you have to have enough math background to look at it and say, that doesn't make sense, or that, okay, I believe that, because if you're supposed to type 100 and you type 1,000 in, the modeling software is not going to care. It's going to give you the answer. You just have to look at the answer and know that doesn't make sense. So where did I make my mistake? And that's a lot of the math background that I use now is how I was taught to think and how I was looking at stuff, and does it pass the smell test to make sense?
The next question, this is actually a really good point. How would you recommend increasing interest to students to get them interested in engineering, and specifically female students, because it does seem like engineering is a male-dominated field. So how can we increase interest and maybe even try to bring in some more female students into our engineering programs?
I think things like this right here are beneficial, where students get to see what engineering offers and see what science, technology, and some of the other engineering and math programs are out there. My experience growing up in a small school, I graduated in the early 90s, which seems like forever ago, is everyone I graduated with, I can tell you 50% chance now of what they're doing, because they're either doing typically what their parents did for a career, or school teacher because they saw school teachers every day of their life, or doctor, pharmacist, or nurse because they interacted with those people. When you're in an area that doesn't have a lot of engineers, you don't produce a lot of engineers. When you're in an area where there are a lot of engineering, and you, as as a student, you end up knowing people who are engineers. You can kind of gravitate toward that. But I think this right here is a great opportunity to show people what's out there so they can be exposed to more than just that small sphere of influence that they have at home and their select group of friends, parents, friends.
Very good point. Jeff or Bill, either of you feel like chiming in on that?
So prior to the pandemic, LCEC partnered with several technical high schools and hosted a career day at our office where we bring in the students, we let them talk to different engineers about the specific jobs they're doing. And we also have a kind of a show and tell demonstration that we put on with our line workers, showing some of the equipment that they use. So I think programs like that are a great opportunity also.
Thanks. Jeff, anything?
Yeah, I was actually trying to call one of my colleagues in. She's actually a female engineer. I was going to see if I could get her in here, but I couldn't. But what I do know about her story is that she originally went into school to be a lawyer, which I feel like, you know, the way society is, that, you know, that is, they've kind of opened that up to make it, you know, more the status quo for females. And you're right, but I would say increasingly I see more and more females in the industry. So I think, you know, with all the career stuff that the schools are doing, that is doing a good job. But, you know, there's nothing, I would say just more exposure, you know, letting people know what engineers do, and that it's accessible to anyone really that has the will and want and and interest in learning things.
Thank you. Very good points. And students, if you are ever interested in, you know, job shadowing or talking one-on-one with someone who is already in this field, reach out to your teachers. They have contacts. Reach out to me. We can always get you in touch with someone that would be willing to just kind of talk to you and explain what they do on a daily basis and what their life is like. So like all three of our panelists have said, just exposure. So a lot of it, sometimes students, is on you to put yourself out there and to ask the question, and to put yourself in a situation where you have the opportunity to experience all of these different career fields. Next question that came in was, what is the starting salary? So average, let's do starting, and then let's do the opposite too. So in your specific field, whether it's at LCEC or at your own individual firm, what would the starting pay be? And then what would kind of be top level? So let's start with Bill.
So I believe the starting salary for an entry-level engineer is about $60,000 right now. And, you know, someone with 20 years experience, probably making $110,000.
Okay, thank you. Shawn and Jeff, anything to add to that?
I would say that resonates to our industry as well, which is not electrical, you know, in the land development field, but so probably that 60ish range, you know, right when you get out of college and you're doing your engineering internships. And but the great thing about engineering though is, you know, there's never really a cap, because the field is so broad. You know, you can turn that into being an entrepreneur. You could, once you get into project management, you can get in, if you like that side of it more. I mean, you can really take it as far as you want to go with it. or you could be like an Elon Musk or somebody who, has a real, the richest man in the world. So.
Yes. Thank you. Shawn, anything you want to add?
Just that there's multiple different types of engineers, and that there are different scales in there. You have civil, you have industrial, you have electrical, you have computer, you have chemical, you have mechanical, and those are just the big overarching ones, and you can dive down into some of them and get into some of the subgroups. So, and some of them start out at higher salary than others. Some of them start out at lower, and they just depending on what you do and where you go. And a lot of times, once you get an engineering degree, that opens the door for other things. I'm a chemical engineer that got my start in power plants doing control systems, and now I'm working in the electrical field. So I've wiggled around a little bit, and I have friends I graduated college with that can't figure out why I'm doing electrical distribution, but it's something I enjoy. And even though I didn't if I could turn back the clock, I would have been an electrical engineer knowing I was going to do this, but it didn't close any doors or hold me out.
Awesome. Shawn, I also see that you had posted a message saying that a lot of people that you graduated with are now doctors and lawyers. Do you want to kind of touch on that a little bit?
Yeah, one thing that I saw in college is a lot of people started out as pre-med or pre-law, and when they graduated, if they chose not to or weren't able to get into medical school or law school, they didn't necessarily have a fallback plan. Whereas people I was in engineering school with, one of them actually saw my daughter when she messed up her ACL, and he just got off his internship with the orthopedic surgeon for the Cleveland Browns or the Pittsburgh Steelers. It was one of the Ohio NFL teams. So, and after talking to him a little bit, he said the engineering program really prepared them well for the medical field. And he also grinned and said, if I found out I didn't like med school, I had a pretty good fallback plan. And a lot of times when you see attorneys ads on TV, it's the slip and fall lawyers. It's the, call me if something bad happened to you. There's a whole field of attorneying out there where if someone invents something technical, they have to get a patent. It's called patent law, and patent lawyers have to have a good technical background and understanding what they're writing and how they're going to defend it. And that is a very niche market that makes very good money. So engineering can be a stepping stone to something else as well as an end to itself. So I just wanted to bring that up because just because you go to chemical engineering school or electrical engineering school or civil engineering school doesn't necessarily mean that you're going to be that for the rest of your career. Another engineer I graduated with is currently the CEO of a homeowners insurance company that sells to the bulk of the Southeast, and he managed to get his way into that somehow because he had the skill set and worked his way through it. So just because you get an engineering degree, there are a lot of engineers that start in engineering, stay there till they retire, but there's a lot of us that start in one thing and jump around and end up somewhere completely different. So keep that in mind. And the other thing I will say is if I'm talking to people between the ages of 12 and 18, 6 years seems like forever. When you're 30 years old, 60 years doesn't seem that long. And when you're in your 40s, 6 years is almost nothing. So please take a little bit of perspective on time, because don't make a decision on what I can do in 1 year versus 4 years when you're 18, because you're going to be working for a very long time. And when you're 40, you'll look back and you'll blink and be right in 2021, and you'll be thinking, I remember when we went to 2020, and that seems like about 2 years ago. Or I'm sorry, not 2020, 2000.
2000. Good point.
I just wanted to add one thing to what Shawn was talking about. One of the programs that I know is available at FGCU. FGCU has a bioengineering degree, which I know we haven't got any questions on that, but there are a lot of people that use the bioengineering degree as a step to med school, because med school, I know, is pretty competitive, and having a bioengineering degree, I know, sets you apart in that field. So that is something that's available locally, that you could do a 2+2 and then go on to be a doctor, or if you prefer the engineering field, you have a bioengineering degree.
Awesome. Thank you for explaining that pathway. We are at almost 10 o'clock, and I want to make sure that I'm respectful of our panelists' time. So last question, we'll kind of wrap it up with this, and I'll go around and give each of you a chance to answer. What does your industry look like 5 years from now? What gaps do you see now that are going to need to be filled over the next 5, 6, 7 years? Bill, we'll start with you.
No, I really don't see much changing in the electrical distribution industry over the next 5 years. The two things that can create change in our industry are legislative changes. So if we have new laws or regulations implemented, or if there's some advancement in technology. These changes historically occur slowly. For example, the integration of renewable resources, which started well over 20 years ago, is a slow process. We're changing, but it's slow. It's nothing drastic. So I really don't foresee any major changes in our industry. And power delivery is a very stable industry. It's, you know, we've been in this business for well over 100 years, and I do not see the demand declining in the foreseeable future. So if, you know, someone is looking for a stable career path, energy, power is very stable.
Awesome, thank you. Jeff, what about in civil engineering?
Over the next 5 years, I mean, right now everything is looking good, but you know, being in land development, we are kind of at the mercy of people building homes, and that will never stop completely. But you know, as we saw back in 2008, it can come to a halt sometimes. I would one thing that I wanted to touch on is in engineering is there a lack in the industry that I'd say right now is the average, as part of land development in engineering, is surveying. And I know that the average professional surveyor and mapper, which is part of the technology portion of engineering and technology, I think the average professional surveyor mapper it's either 55 or 58, which means that there are not a lot of people going into that industry. In the qualifications that you need are geomatics degrees, which I think are only available at University of Florida and FAU, or you need quite a bit of experience. I think it's 6 years of responsible charge in that industry. But surveying itself, I know, is getting increasingly technological with all kinds of radar and LiDAR, GIS systems. There's I think that there's a real lack of just knowledge about the field in general, and I feel probably in the next 5-10 years, those professional surveyor and mappers that are 55 will be 65 and they'll be wanting to retire, and I don't know if there's going to be enough qualified people to replace them. So that's definitely a field to maybe start looking at if you guys really like technology and computers and mapping. that's kind of what I got for maybe a lack over the next 5 years.
Thank you. Thank you for that. Shawn, I see you unmuted, so feel free.
I'll go on with what Bill said. The electric utility industry is very stable. Have friends that work in other industries, and I jokingly tell them that your stuff doesn't work unless our stuff works. So we have to keep the lights on. We're a foundational industry. I jokingly say that the economy has to get really bad for people to turn their air conditioners off in Florida during the summer. So there'll be a lot of things when the economy slows down that'll go by the wayside, but the electric utility is probably the last thing to be terribly impacted. I've worked at several places, and one thing that we've always noticed in talking with other people in the field is we have trouble finding qualified engineers, ones that are willing. And my brother-in-law, who's a civil engineer, broke it down to, we're having trouble finding people that know work starts at 8 and goes to 5. You have to show up at 8, you have to stay till 5. So if you have a work ethic where you can do, it used to be if you wanted to get ahead, you showed up 30 minutes early, stayed 30 minutes late, and that has shifted to you show up on time and you leave on time. And there's a lot of opportunity for young engineers who are willing to show up and do the work. Electric utility across in Arkansas and Oklahoma, where I worked previously, there weren't a lot of young ones in the field where I was in the companies I was dealing with, which means, like Jeff said, 55 turns into 65. And when most of your engineers are in their 40s, it's not going to be long before there's going to be a need to bring in a whole new flock of people. And that's starting to be seen. So in the electric utility industry, I don't see the industry changing very much very quickly, but I see a lot of opportunity for young engineers that are willing to work and come in and do the job. So I think the sky is the limit. And if you're one of the ones that will excel and put forth a lot of effort to do well, you can make a very good career for yourself and end up going places.
Awesome. Thank you. Thank you all so much for that. So it's good to know that the engineering field is here. It's here to stay. And there's going to be a lot of opportunities, especially as older engineers are retiring. So students, if it's something that you're interested in, definitely pursue that, because there will be enough job openings for any of you who are interested. Well, with that, we're going to go ahead and close. Do any of you have any last parting words, any last things that you want to get out there that you haven't had a chance to share? All right. Well, if not, thank you all so very much for taking an hour out of your day to meet with our students. Students, thank you for joining in. If you're watching this at a later date, please feel free to reach out with any questions. And thank you all. Have a happy Wednesday, and we'll see you in 2 weeks. Thank you, panelists.
Goodbye, everyone.